Hey everybody, happy Friday. Hope you all had fun with yesterday's video and understood it because today's section is very similar. I'm just going to add one more piece to U-Substitution and see if you guys understand it. I'm not sure if you had this in your notes. I forgot if I gave this to you in a gigantic packet. I'm pretty sure I did, but in case some of you don't have it or you lost it, I made some copies. So you want to take this out on your notes. Again, you could pause me if you need to take this out. So yeah. So hopefully by now you have your notes. I'm going to go over this. So this section, again, it's as you can see, it's integration by U-substitution, but we're doing definite integrals. And in case you forgot what a definite integral is, you can look at these examples at the bottom. The difference between these problems and the ones you did yesterday, if you guys notice, is that they have now numbers or bounds, a lower bound and an upper bound, for which I want to actually evaluate and get a number for the integral. Okay. If you look at steps 1, 2, 3, 4, the exact same steps you practiced yesterday. So you're going to find something to set to u, you're going to take and find du, and then 3 and 4 you're going to substitute it back into the original problem. So all that stuff that you remember from yesterday. The difference is that now I have these two numbers. We're going to actually change those numbers because we're going to change the problem into u's, which means we're going to change these two numbers also, and then integrate. And anytime you have a definite integral, you're going to be getting an actual number. Okay, so we'll go through 3 examples and see how hard or difficult it is. And if you don't get it, we'll go over it on Monday. So looking at the first example, again, I can tell this is a definite integral because I have numbers here on the bottom and the top. So what I'm going to do is I'm going to need to find u, not find u, but the letter u, and which, in this function, which expression do you think I should call or designate to be u? What's my inside function? Yeah, it's going to be 27 minus 19x squared. So you're going to write that down real quick. If that is u, what would make du? Yeah, the derivative is going to be negative 38x dx. So now, if you remember from yesterday, this whole thing underneath the radical, this all becomes a u. But I'm still stuck with an x, and I'm still stuck with a dx once I do that u substitution. So to get rid of this x dx, in my second equation, I need to get x dx by itself. Would you know how to get x dx by itself? Yeah, I'm going to divide both sides by negative 38. So x dx is actually negative 138 du. So now I can do my substitution of the integral. And this cube root of 27 minus 19x squared now becomes simply, again, we're trying to make this problem simple, just becomes a cube root of u. Okay. My x dx, you remember, now becomes negative 138 over du. But you may notice that I'm missing one piece. I neglected to put one piece in there, and you notice I didn't put the bounds in. Because these bounds represented what they were when there's x's, I also have to change these numbers as well. How do I change these numbers? You take each number, and you're going to plug it into your u equation to get what the new bounds are going to be. So if I plug 0 into my u equation, 19 times 0 is 0. 27 minus 0 becomes 27. So again, all I did was plug in 0 into x of my u equation. Now let's do the upper bound. If I plug in 1 into here, I get 19 times 1 squared, which is 19. 27 minus 19 is 8. And somebody might be confused or lost or wondering, initially this was a bigger number than the bottom and now it's flipped. It's okay. I'm just doing the u substitution and that's how I get it. So now it's going to be solving the problem just like we used to always do. First thing I'm going to do is I'm going to take out this negative 138 and put it out in front. I'm taking the integral of 27 to 8 of, and again, I don't know how to take the integral of cube root of u, so I'll call that u to the 1/3. Now I'll take the integral. Remember, I add 1 and divide by it. If I add 1 to my exponent, this 1/3 now becomes 4/3. And when I divide by 4/3, it now becomes 3/4. So the integral of u to the 1/3 becomes 3/4 u to the 4/3 from 27 to 8. Okay. And now some of you may be confused, what do I do now? What's the difference? The great thing about definite integrals, if you remember from U-Substitution, remember I had to plug x back in, or I had to put everything back into x? The great thing about definite integrals is that the answer should be a number, so I don't have to plug anything back in. I don't need to put it back into x's. All I'm going to do is just plug in these numbers. So if it's going from 8 to 27, if you guys remember, it's been a while, I'll plug in 8, I will plug in 27, and subtract the two values. Also, you'll notice that you see how this 3/4, and remember in this previous problem where I had this negative 1/38, I could pull this out? Well, same thing with this 3/4. Now that I have a 3/4 out here, I could also pull that out before plugging in the 8 and 27. It'll make your life a lot easier. So it'll be 3 over 152. And then I'm going to plug in 8 to the 4/3. And I'll plug in 27 and subtract the two values. Okay. As we did this before Christmas break, this is way easier if you have a calculator. 8 to the 4/3 is 16. And you put it into your calculator. So negative 3 over 152. 16. And if you put 27 to the 4/3 in your calculator, you're going to get 81. Okay, so far? So now, 16 minus 81 is 5, 65, 65? Or negative 65? Okay, so far? And then, negative 3 times negative 65, I'll multiply that out. So you're going to get 5, 195, negative 195 over 152. And I don't know if that reduces or not, or you can put that in calculator and get a decimal, but that is how you do definite integrals. So it's not a pretty answer. Most of these aren't very pretty answers, but that's how you find out the definite integral. So exact same process, only difference is that I have to change the two numbers on the bounds and then plug them in and subtract the two values. Okay? We'll do two more examples. If I have more time, I'll do two more example problems. So let's just kidding. Let's why don't you delete? Alright. Gone. Alright. Example number 2. What's going to be my u for this problem? Yeah, x squared plus 4. If that's u, what's du going to be? Yeah, 2x dx. Again, I'm going to analyze my problem and see what do I have to replace. This right here is going to turn into u. And what x's do I have left? Yeah, I have this x dx, which means in my du problem, I need to get x dx by itself. So let's divide both sides by 2. So half du is x dx. Okay. So let's replug that in back to the equation. Let's turn this problem into all u's. So this x dx, sorry, disappears and it just becomes half du. And then the fraction with the x squared plus 4 over the bottom now just becomes 1 over square root of u. Now I got to change the bounds. In case you forgot, I will take the bound, and here I'll annotate it for you, and I'll plug them into my u equation. So if I plug 0 into here, 0 plus 4 is 4. If I plug radical 5 into here, radical 5 squared is 5. 5 plus 4 is 9. So there's my new problem. I change the bounds, 4 and 9. I change the bounds, 4 and 9. This x squared plus 4 became a square root of u, and this x dx became a half du. Okay? Now I solve like normal. I will pull out the half first, and now I get 4 and 9. And again, this is something I cannot take the integral of. This 1 over radical u. That could be rewritten as u to the negative half. Okay, du. To take the integral, I will add 1. So let's do the integration. So if I add 1, this becomes half. And then dividing by half, I'm going to get 2. Okay, just like our original problem, this is just like remember when I pulled out the half here? This is the same thing. I have this 2 inside the brackets. I could factor out a 2, and 2 times half is just 1. So this problem can just be simplified to u to the half, and then 9 and 4. Okay. Next thing I'm going to do is I'm going to plug in 9 and plug in 4 and then subtract them. So this whole problem becomes 9 to the half minus 4 to the half. You should know how to do this in your head, or if you feel uncomfortable, you could use a calculator. 9 to the half, or the square root of 9 is 3. 4 to the half, or the square root of 4 is 2. 3 minus 2 equals 1. Ta-da! And that's how you do it. Okay, one last problem. Let's see if I could rush through this, and maybe if I have some extra time, I could show you some pictures of the baby. U in this problem will be pi over 12t. Okay. Looking at my problem, the only t that I'll have left is this dt. Let's take du. So if u is pi over 12t, du will just be pi over 12 dt. Now I look at the problem and I notice that I just have dt. That's the only thing I need to replace. So I will get this pi over 12 and move it to the other side, or I'll divide both sides by pi over 12. And remember, dividing by a fraction makes me flip it. So if I divide both sides by pi over 12, it becomes 12 over pi du. And let's put this in the problem. I'm going to get cosine of u. And this becomes, this dt now becomes 12 over pi du. I need to change my bounds. So my bounds are 4 and 6. So I'll plug in a 4 in here. 4 times pi over 12 becomes pi over 3 when you reduce. And if I plug in 6, it becomes 6 pi over 12 or pi over 2. Okay. So I change the bounds, convert it into use. Very first thing, I'll pull out 12 over pi. The bounds are still here. Sorry, it takes a while. Cosine u du. Now, do you guys remember what the antiderivative of cosine u is, or what the antiderivative of cosine is? Yeah, it's sine. So 12 over pi, bracket, sine u. Sine u of pi over 3 and pi over 2. And some of you may have forgot how to do this. Sine of pi over 2, in case you forgot, sine of pi over 2 is 1. And sine of pi over 3 is radical 3 over 2. You could use the unit circle, you could use your calculator. And actually, I'm just going to have you stop right there. I think this answer is much better than a decimal or anything like that. So at some point, just plug in the numbers and stop there. In class, I want you to do this worksheet. I'll have you do just the odds. You're going to turn it at the end of class. I want you to be efficient. Make sure you get everything done on time. With about a minute left in the video, some people wanted to see a picture of the baby or if the baby is real. Some people said that they noticed or heard the baby crying in the background. I'm sorry. So I'll leave you guys with a couple pictures so you guys can see some. So here's Trey, or Eddie the Third. He's very alert. He's tiny. That's how he looks like. I don't know how to narrate this picture slideshow of Trey, but and then he is knocked out. So there you go. There's some brief pictures. I can show you guys more when I get back. Hope you all have a good weekend. I don't want you guys to do any homework, and we'll tackle this stuff when I come back on Monday. Take care, and see y'all soon.